All right, we're going to do a few examples of volume of solids of revolution using the disk method. And we're going to start with y as our axis of revolution. So let's say you're given the following function. You're given y equals x cubed. Okay. So it will look something like this. Something like this, right? So if y equals x cubed, and you're asked to find the volume within the region of y is equal to -8 and 8. All right. So you know that your disks are going to be something like this. And when this revolves around the x-axis, it's going to create something like this, right? And this is your dy. So you're going to have a horizontal cross-sectional, if you will. Okay. All right. So we know using the disk method, our volume is going to be pi times, and our A value here is -8 and B is 8. So it's going to be from -8 to 8 r squared dy, or it's pi times the square root of -8 to 8 f of x, sorry, not f of x, f of y squared dy. Okay. So what we have right now, we have y equals x cubed. We need to solve for x so we can have our function, our equation as a function of y, right? So we know that x would be the cube root of y. Okay. So when we plug in, we have our volume is going to be pi from -8 to 8 y 1/3 squared dy. And I'm just going to simplify this a little bit. Pi -8 to 8 y to the 2/3 dy. When we integrate that, we're going to have pi times y to the 5/3 times 3/5 from -8 to 8. Now you can make this a little bit simpler for yourself and go from 0 to 8 and double this integral. But this will end up being 192 pi over 5 unit cubed. Okay. All right. So let's do another one. Okay. Let's do that. All right. Okay. Let's say we have y equals 4 minus x squared. And our region is from x equals 0. So let's draw this out first. So let's say 1, 2, 2, 1, 2, 3, 4. Okay. So if you're doing, we want to do around the y-axis. Okay. So our dy, or our disks, if you will, is this right. Sorry, our disk is horizontal, and this is our dy, right? Okay. So we know if we're going from if we're looking at this region right here, right, based on the graph that we have, it's going to be from y equals 0 to y equals 4, right? Or you can be told between, actually, yeah, this, you could be told between -2 and 2, but since we're doing our revolution around the y-axis, we care about our y value for our interval, right? So our volume, again, is going to be pi times the integral a to b, and our f of y squared dy. Again, this can be rewritten. In this case, is from y equals to 0 is to y equals 4, 0 to 4. And we need to solve, this is our radius, right? We need to solve for x so we can have our function, our equation as a function of y. So we have here y equals 4 minus x squared. And we know that x squared equals 4 minus y. And x will have to equal 4 minus y, the square root of, right? So this is our function, if you will, f of y, right? Or our radius, right? So when we plug in, we're going to have 4 minus y, the square root of, squared dy, and this cancels. So you're going to have pi, the integral, times the integral of 0 to 4, 4 minus y dy. And that's an easy power rule, and that will give you pi times 4y minus y squared over 2 from 0 to 4, and that should give you 8 pi units cubed. Okay. All right. All right, I'm going to do another example using the disk method. But this time we're going to have it around the revolving around the x-axis. Let's say we have y equals the square root of 9 minus x squared. Okay, so if we're to graph this, we will have 1, 2, 3, 1, 2, 3, and 1, 2, 3. So it looks something like this, right? Not so pointy, but more rounder. Okay. So our revolution is going to be around the x-axis. Okay. So our function, our equation is already as a function of x, and we're going to have vertical disks, if you will, and our function is revolving around the x-axis. So when we look at our interval, it's going to be from -3 to 3. We know that is going to be a sphere, but let's see if we can solve it using what we know with calculus, okay? So using the disk method, that we know the volume is going to be pi, the square root of, from -3 to 3, -3 to 3, and our function is a square root of 9 minus x squared, right? So the square root of 9 minus x squared dx, right? So this cancels out. So we're going to end up with -3 to 3, 9 minus x squared dx. So this is a simple power rule, and this will give us 9x, sorry, I'm just going to write it below, pi times 9x minus x cubed over 3 from -3 to 3. And I can make this a little bit easier on myself and rewrite this as 2 pi from 9x minus from 0 to 3. I'm just, because it's symmetric, I can just break it in half. Okay, it just makes the plugging in the values a little bit easier. Okay, so you will have 2 pi 9 times 3 minus 3 cubed over 3 minus 0, right? 2 pi times 0. Let's be consistent. So this is 0, okay? And this will give us 9, right? So we'll end up with 2 pi 27 minus 9, which will give us 36 pi units cubed. Okay. And we know for a volume of a sphere is, this is a side note, V equals 4/3 pi r cubed, right? And if we were to plug in our values for our radius, we know our radius is 3, right? This will end up giving us 4/3 times pi 3 cubed. And this will end up giving us 4/3, actually. This would cancel out and give you 9, right? So you'll have 36 pi. So the answer is the same, but in this case, we're using what we've learned in calculus to solve for the volume.